Let's take a look at the picture plot and the Flipbook animations. In picture plot, we'll open that up. Open the Casio folder. G3B, which are Flipbook animation files. We want to find the file called Jump and Fish. Press the letter J to get a small preview. Toggle over. That's the one we want. Execute. We've got some data on there, so let's eliminate the data. Option, delete. Now let's press play. We'll let it go once. We'll get to see what the animation looks like. Looks like there's a fish jumping from one bowl to the other. To stop the animation, I'll press AC on. And now let's plot. Option, plot. You get the small arrow, which lets you plot the X coordinate, the Y coordinate, and also a time component. Execute. It'll advance one frame. What we want to do is find the center of gravity of the fish. At any point you can stop the motion and find, for example, if we stop here, I can find the angle of trajectory of the fish as it leaves the bowl. And we can fit a linear regression on here. We want to go ahead and find a quadratic regression for the motion of the fish. So we're going to keep going, tracking the motion of the fish, and the computer will continue to find X, Y, and T, and then we'll be able to look at the X and Y positions in terms of time separately. A few more. We were just chasing the fish around the bowl. And then we will get to the last one right after this. And there's some distortion in the picture due to the refraction of the water. There we go. Finish plotting, exit. Now what I want to do is find a regression. Option. We'll press option. Oh, let's hit exit again. Regression. X squared. Copy. Draw. There's my regression equation. Now we can take a look at the motion of the fish by looking at the axes. In this case, if we look at time versus the Y position, we get a parabolic. If we look at the X versus T, time versus X, time will continue to go linear. You can find regressions for each one of those. If you would like to look at the data, there's your X position, your Y position, and your time position. Once you have the curve, once you have the information, you can go ahead and find the best fit line and also the intersections, the max, the roots, the minimums, etc.